behave with love.
Good day, my students. I'm happy you are back to the class today again. I want to believe that you found this course interesting as we navigate from one study section to another. And I really quite happy that you are paying good attention and you are learning here. As usual, my name is Dr. Donye Dauda Yusuf, and I'm still going to be the one to continue to teach this course, and I'm believing you're understanding and you're following. We have dealt extensively with 3 study sessions so far. The number systems up to exponent and roots. Today we are going to start with another study session, which is our study session 4, the systems of equations. We are going to look at this the systems of equation, and I want to believe that the following shall constitute our learning outcome: to explain broadly the meanings of equation system. Yes, and we are going to solve problems of linear equations using substitution method. We are also going to solve problems of linear equation using the additions and subtraction method. We are going to try to understand graph systems of equations solution. By way of our introductions, when we talk about equations, we simply mean 2 different numbers are equal to one another. So we have different types of equations, such as the linear equation, exponential equations, polynomial equations, quadratic equation, trigonometric equations, radical equation, and so on and so forth. Solving equations means finding the value of a variables or unknown variable contained in the equation. So let's introduce ourselves to the systems of equations and graphing. A system of equation is a set of 2 or more equations with the same variables. The equations is a set of 2 or more equations with the same variables. A solution to a system of equations is a set of values for the variables that satisfy all the equations simultaneously. To solve problems on systems of equation, example, which of these sets of figures is a solution to the equation below? So let's say when you open the bracket, the outer bracket, I will say 4, 5, and you open another bracket and close 8 and 3, another bracket 6 and 4, another bracket 4 and 6, another bracket 7 and 2. Y plus 2x is equals to 14. So we say xy is equals to 24. That is 2 times. Let's say that is equation 1. So let's say 4 and 5 in the bracket is a solution of the first equation, but not the second. We need to find out why 4 and 5 satisfy the first equation, but fail to satisfy the second equation. First, let 4 represent y and 5 for x. In this context, our equation becomes 4 plus 2, open bracket 5, plus is equals to 4 plus 10 is equals to 14. The above equation gives an answer of 14. Thus, it satisfies the first equation. Now, let us see if it satisfies the second equation. That is, xy is equals to 24. So let's continue to the next our study, to solving systems of linear equations by graphing. As we earlier indicated, an exponent involves the numbers of times in which a number is multiplied by itself. For example, 7 to the power of 2. Here, 7 is the base and 2 is the square, indicating 7 multiplied by itself. based on our definitions of exponent. When we multiply 7 by itself, 7 times 7, we got 49. Similarly, the square root of 49, that is the square root of 49, that is the square root of 49 is 7. Let us try with another number. Take 5 for instance. Let us find the cube root of 5, meaning 5 to the power of 3. Here, what we simply means is 5 times 5.5 times 5, which will give us 125, converting cube root to this. So, example, y is equals to minus 3 plus 3. 2y equals to 2x plus 6 from equation 2. 2x plus 2y is equals to 6. Open bracket, that is, let's say this is equation 2, y. So y is equals to 2x over 3 minus 2, and y is equals to 4x over 6, open bracket close, minus 12 over 6. 6y is equals to 4x minus 12 from equation 1. 4x minus 6y is equals to 122x plus 2y is equals to 6. This is equation 2. So 4x minus 6y is equals to 12, equation 1. Solve the following system by graphing. So graphical representations. In the above solutions, the slope for the first and second equations are 2 over 3 and minus 1 respectively, while the y minus intercept are minus 2 and 3 respectively. So you can study it critically from the graph below. You can see that y is equals to minus x plus 3, which is equals to, in bracket, 0 and 3. So if you check the y-axis and the x-axis, you will see that y is also equals to 2x over 3 minus 2 is equals to, open bracket, 0 and 3. So let's solving systems of linear equation by substitutions. So let's look at the example 1. Solve the following system using substitution. Let's say 6x plus 2y is equals to 14. Let's say equation 1. Then 4x equals to 16 minus 6y equals to the equation 2. The easiest variable to isolate is y in the first equation, thus from 1. So let's say 2y is equals to minus 6x plus 14. Then we say y is equals to minus 3x plus 7. In the second equation, substitute y for its equivalent expressions. So we say 4x is equals to 16 minus 6, then open bracket close, minus 3x plus 7. Solve the equations. We say 4x is equals to 16 plus 18x minus 42. So we are now saying, okay, 18x minus 4x is equals to 42 minus 16. So if you mind that you have 14x is equals to 26. So to get to the last answer, we say x is equals to 26 over 14, which will give us x is equals to 1.86. That will now make this one equation 4. Now substitute this x value into the isolated equation to find y. So you say y is equals to minus 3, open bracket, 1.86 close the bracket plus 7, which is equal to 1.42, which this can give us our equation 5. So now example 2, solve the following system using equation in substitutions. It says 2x plus 4y is equals to 36. Let's say equation 1. Then it says 10y minus 5x equals to 0, equation 2. It is easier to work with the second equation because there is no constant terms. Get it? There is no constant terms. So what we are going to have? So from equation 2, we say, okay, 5x equals to 10y. And then x is equals to 2y. That is equation 3. Then we say, okay, 2 open bracket, 2y, close the bracket, plus 4y is equals to 36. So we have 8y is equals to 36. And y is equals to 4.5, and this should be our equation 4. Then you plug this y minus the value into 3 to find x. So you can say, all right, x is equals to 2y is equals to 2 open bracket 4.5 close the bracket equals to 9. Let's assume this is our equation 5. Thus, the solution to the system is 9 and 4.5. Since so solving system of equations by additions, we are done without substitutions or subtraction. Another way of solving systems of equation problem is the additions and subtraction method. In the addition or subtraction method, we add or subtract the two equations from one another in order to create a new equations with only one variables. So solving system of linear equation by additions and subtractions. Example 1. Add and subtract to create a new equation with only one variable. So we say 2x plus 4y is equals to 3. That is equation 1. Say x plus 3y is equals to 13, equation 2. Here we can multiply equation 2 by minus 2 and equation 1 by 1 and then add. So we say, okay, 2x plus 4y is equals to 3 and minus 2x minus 6y is equals to minus 26. Adding these two equations yields minus 2y equals to minus 23. Then here now we say y is equals to 23 or minus 23 over 2. This example 2. Add and subtract to create a new equations with only one variable. So here we say, okay, 4x minus 2y is equals to 16. Equation 1. 7x plus 3y is equals to 15. Equation 2. Here we can multiply the first equation by 3 and the second equation by 2 and then add them together. So we are having 12x minus 5y is equals to 48. And we're also adding 14x plus 6y is equals to 30. Adding these two equations yields 26x equals to 78. That is, x will be 78 over 26. If you check the two answers, the first y equals 23 over 2, while the second is giving you x is equals to 78 over 26. Now let's move further. Let's look at the solving systems of linear equation by multiplications. We are done with additions and subtraction. Let's look at it with multiplication. Solving the following systems of equations. When we say 2y minus 3x is equals to 7, and we say 5x is equals to 4y minus 12. Rearrange each equations. When you rearrange, you have minus 3x plus 2y is equals to 7. Let's consider it to be equation 1. And we say 5x minus 4y is equals to minus 12. That is equation 2. So multiply the first equation by 2. So you say minus, that will give us minus 6x plus 4y equals to 14. And 5x minus 4y equals to 12. Add the equations. You will have minus s is equals to 2. They solve for the variables. So when you are solving for the variable, we'll say, okay, x equals to minus 2. If you plug x equal to minus 2 into one of the equations and solve for y, e.g., in example 1, you see that we have minus 3, open bracket, minus 2, close the bracket, plus 2y is equals to 7. So we are saying 6 plus 2y is equals to 7 and 2y is equals to 1. Therefore, y is equals to 1 over 2. Thus, the solution to this systems of equation is minus 2, or 1 over 2. Are you getting? So let's check this result and see. If you say 2, you put a bracket 1 over 2 minus 3, when you are equals to 3, open bracket minus 2, close the bracket, it equals to 7. Therefore, 5, or if you open bracket minus 2, close the bracket, equals to 4 over 1 over 2, close the bracket, is equals to, open bracket close, equals to minus 12. Therefore, you will have minus 10 is equals to minus 10. So let's look at the example 2. Solving the following systems of equations. So we have 5y minus 4y minus 5 is equals to 20 minus 3x. And you also have 4x minus 7y plus 16 is equals to 0. So if you rearrange each equation like we did in the previous example, you will have 3x plus 4y is equals to 24. this time around, let's consider this to be equation 1. And 4x minus 7y is equals to 6 minus 16. That should be made equation 2. So multiply the first equation by 4 and the second equation by minus 3. So we will now have the first equation will now have 12x plus 16y will be equals to 100. That is, the second will give us minus 12x plus 21y is equals to 48. Add the equations. Now, you will have 37y is equals to 148. So y will be equals to 4. So let's go to solve for the variables. So y is equals to 4. When you plug y into 4, which is equals to 4, into one of the equations and solve for x, you will say, okay, since you say 3x, which is, let's use equation 1, 3x plus 4, open bracket, 4 will give us 25. So you say 3x, and you say 4 times 4, that will give you 16. So 3x plus 16 will be equals to 25. So when you transfer 16 to that end, 25 minus this will give you 3x is equals to 9. So if you divide 9 by 3, you will say x is equals to 3. Thus, the solution to the systems of equation is 3. So let's check. When you substitute, let's check for 3 and 4. When you substitute, 4 into 4 minus 5 is equals to 20 minus 3, open bracket 3. So this will give you 4 times 4 will give us 16 minus 5 is equals to 20 minus 3 by 3 will give us 9, which equals to, so 16 minus this 5, and this will give us 11 is equals to 11. The same thing if you substitute with 3. 4 into 3 minus 7, open bracket 4 is equals to minus 16. So if you say 4 times 3 will give us 12 minus 7 times 4 will give us 28. So minus 28, which is equals to 16. Therefore, we will say minus 16 is equals to minus 16. Thank you for your kind listeners and their attention in this class, and I hope we'll meet in our next class. Thank you very much. Have a beautiful day.